Hello, welcome to my class. My name is Teacher Sarah, and today we will be discussing about measurements and calculations in caregiving. Okay. So why measurements and calculations in caregiving? Well, it is being used in first, meal preparations. Second, in computing calorie and nutrient needs of patients. Third, in administering dosages of medicine to patients. Okay? So before we proceed, we will define some words first. So first is dosage. When you say dosage, a measured amount to be taken as in medicine. The second is desirable body weight. So from the word desirable, so it means weight in kilos or pounds of an individual considered ideal for his or her height. And third is calorie. It means unit of measurement of food. So this time, we are going to review ratio, fraction, and proportion. So ratio is being represented with a symbol, a semicolon or semicolon. It means comparing two numbers and their relationship with one another. So, example, a thin syrup is represented with 1 to 3. So what does this mean? So it means a 1 cup of sugar is dissolved to 3 cups of water. So it represents with this number 1 to 3. Second is medium syrup. It has a 1 cup of sugar dissolved in 2 cups of water. And then third is a thick syrup. It has a 1 cup of sugar dissolved in 1 cup of water, or 1 to 1, or 1 is to 1. Okay? So next is fraction, represented by symbol slash. It refers to part of a whole. It indicates relationship between two numbers. So example, one bottle of capsules contain 12 capsules. So in equation, 1 is to 12. In fraction, it is read as 1/12 or 1 to 12. So next is proportion. It has a symbol, double semicolon, represents an equation of two ratios or fraction. So it indicates relationship between two numbers. Example, one bottle of capsules contain 12 capsules. The ratio is 1 is to 12 or 1 to 12, and the fraction is 1/12. If there are two bottles of capsules, there are 24 capsules, right? So 1 to 12 is proportionate to 2 is to 24. Or 1/12 is proportionate to 2 over 24. Okay? Another example is every hospital room has 5 beds. So the ratio is 1 to 5. So 1 is represents the hospital, and 5 is represents the 5 beds, and the fraction is 1 over 5 or 1 to 5. If there are 20 hospital rooms, so, so the ratio is 20 is to 100, and the fraction is 20 over 100 or 20 to 100. Okay? So next, another example is solve the x using ratio and proportion. So how many rooms will be needed for 72 patients if 6 patients can be accommodated in a room? So let's take a look. Well, x over 72 patients equals 1 room per 6 patients, or x is to 72 equals 1 to 6. So x over 72 equals 1 over 6. So cross multiply, x times 6 equals 6x. And then 72 times 1 is 72. To get the x, divide to 6. 6x divides 6 and 72 divided by 6. So x equals 12. Thus, 1 to 6 equals 12 to 72, or 1 to 6 proportionate to 12 to 72, or 1 room per 6 patients, or to 6 patients equals 12 rooms to 72 patients. Got it? So next, determining medication dosing in pediatrics. Okay? So in drug dosing for pediatrics, 3 factors must be kept in mind. So first is the age. Second is weight. And third is clinical condition. So before we proceed, pediatrics means children. Okay? So age. Pediatrics subdivided into categories. So first is newborn. Then second, infants. Then third, toddlers, children, and adolescents, in which a standard or linear dose according to the kind of medication is selected. So second is weight. So medications in pediatrics is calculated according to the patient's weight with the use of this formula. So milligrams divided by kilograms divided by dose. Example, calculate the dose of amoxicillin suspension for a 6 years old child with a weight of 25 kilograms. Dose required is 20 milligrams per kilograms per dose, and the suspension comes in concentration of 400 milligrams per 5 ml. So how would you do that? So first, calculate those 2 milligrams. So 25 kilograms times 20 milligrams per kilograms per dose equals 500 milligrams per dose. So that, just multiply this on 25 times 20. Then letter B, convert milligrams over dose to milliliter. So 500 milligrams per dose divided by 400 milligrams per 5 ml is equal to 6.25 milliliters of or per dose. So next is clinical condition. So medicines are sometimes dosed according to the clinical presentation of the pediatric patient. So next is safety practices in administrating medicines to children. So first, use calculator in computing dosage. So do not rely on just manually computing it. So you should, as a future caregivers, you should always make sure that the calculation is accurate. So second, always read leaflet accompanying the medicine. This is found inside the package. You can also consult a pharmacist if in doubt. So third, follow the steps in mixing oral drugs that come on suspension form carefully, or you can request the pharmacist to do it for you. So if you have experience buying a antibiotic for pediatrics or for children, you will see that it is in a powder form. So you need to dissolve it in a water or a but if you don't know how to dissolve it, the right amount of the water, you may request for the pharmacist to do it for you. The next is fourth, record child's weight in kilograms so it comes in handy when needed. So fifth, a common method of calculating dosage for children is the body surface area or BSA method, also called the dosage per kilogram of body weight method. The formula is average adult dose. Child's BSA is m squared divided by average adult BSA equals 5 child's dose in milligrams. So note that average adult BSA is equals to 1.73 square meter. So these are the rules in calculating drug dose. So first, use correct units of measurements to avoid errors. So always check the units. Second, pay attention to the correct placement of your decimals when making computation. Third, always check and recheck your computation. So it is really important that your computation is accurate. So always make sure to check check it. So this next is measurements and calculations in meal or diet preparation. So letter A, measuring the energy value of food. So the energy value for food is derived from three major nutrients, namely carbohydrates, fats, and protein. So energy value for each nutrient is measured in kilocalories or kcal. Estimation of the kilocalories value of carbohydrates, fats, and protein is measured directly by a BAM calometer. So 1 gram of carbohydrates yields 4 kilocalories. Next is 1 gram of fats yields 9 kilocalories. And then 1 gram of protein yields 4 kilocalories. So in every 1 gram of protein, it has 4 kilocalories. Okay? So these are referred to as the physiological fuel values of food. Example, if you eat a slice of apple pie with 9.6 grams protein, 39.6 grams carbohydrates, and 3.5 grams of fats, how many kilocalories are you getting from this slice of pie? So 36.6 grams of carbohydrates times 4 equals 158.4. So that is 158.4 kilocalories. So 9.6 protein times 4 is equals to 38.4 kilocalories. And then the fat is 3.5 grams fats times 9 equals to 31.5. So total calories of 228.3. So where did we get this one? And then 4 and then the 9. So as we discussed before a while ago, so in every 1 gram of carbohydrates yields 4 kilocalories. So in 1 gram of fats yields 9 kilocalories. And then 1 gram of protein yields 4 kilocalories. That's where we got the 4, 4, and 9. Right? Here, 4, 4, and 9. So another example, if one breakfast meal of banana, lakatan, scrambled egg, plain rice, and hot milk contains 58 grams carbohydrate, 12 grams protein, and 5 grams fat, how many calories are you getting from the meal? Well, so 58 grams carbohydrates times 4. And then 12 grams of protein times 4 is equals to 88. Then next is 5 grams of fat times 9 equals to 45. So that's have a total calories of 365. Okay, next. Letter B is calculating your desirable body weight or DBW. So there are two methods to determine if you are overweight, underweight, or have desirable body weight. So first method is what we call the Tannhauser's method. So first, convert your height in centimeters if it is in feet and inches. So blank feet times 12 since in every 1 foot there is 12 inches. Then add up all the inches and multiply by 2.54 meters to convert it because in every 1 inches is equals to 2.54 centimeters. So here it is. The example. So next is height in centimeters, subtract from the example we have here. My height is my height is 5'1". So let's go back here first. Using the Tannhauser's method. So my height is 5'1". I 5 5 feet and 1 inch. Okay. So convert your height in centimeters, so 5 feet times 12. Since in every feet, 1 foot, there is 12 inches. So 5 5 times 12. So that equals to, so that equals to 60. And then it says here, add up all inches. So here, 1 inch, since my height is 5 feet and 1 inch. So plus 1 is equals to 61. And then multiply by 2.54 because in every 1 inch here is equals to 2.54 centimeters. So 61 times 2.54. So that's 61 times 2.54 equals 154.94. Okay, let's remember that. Next, next is second, height in centimeters subtract from factors 160 centimeter minus 1 equals to 60 kilograms. So this one here is our answer a while ago because my height is 5'1". 5'1". I have a height of 5 feet and 1 inch. So this is already converted into centimeter. So height in centimeters, this one, subtract from the factor 100. So this 100 here is constant. So 154.94 centimeters subtracted with 100 is equals to 54.94 centimeters. So next is subtract 10% to adjust to Filipino weight standard. So this one here, this is weight standard of Filipino. So we should subtract 10%. So 10% of 54.94 is 5.94. No, 5.45. So 154.94, let's make sure of it, times 0.10. So that's 15 rather. You know, 54.94 times 0.10. So 5.494. So that's minus 10% is equals to 49.4. So this is my ideal weight or desirable weight or DWB. So for if your height is 5 feet and 1 inch, so this is your desirable weight body. Desirable body weight or DBW. Okay? This is B. DBW. So next, Next method is Adorno-Dionysius method. So for the first 5 feet in height, allow 100 minus 105 pounds for females and 105 to 100 pounds for males. Add 5 pounds for every additional inch. So if your height is 5'4" or 5 feet and 4 inches and your gender is female, then 5 feet is equal to 105 pounds. 4 inches times 5. So that means 20 pounds. So the desirable body weight is, you add up that one, so 125 pounds. Okay? So where did you get this answer? So let's go back here. So for the first 5 feet in height, 5 feet, allow 100 to 105 pounds for females. So it says here, female, here, with 5 feet and 4 inches height. So we have here 100 to 105 pounds. So, so here it is, 105 pounds. So in every 4 inches, you have here. So add 5 pound for every additional inch. So in you have 4 inches, so 4 inches times 5, because in every inches there is 5 pounds. So we have to multiply this one. So we have here, as a result, 4 times 5 is equals to 20 pounds. To get the cerebral body weight, just add up this one. So 5 plus 0 is 5. 0 plus 2 is 2. And bring down 1. So we have here 125 pounds. So that's how easy this method is. Alright? It's than easier than the Tannhauser's method. Okay? Okay, now this time, I want you to make an activity. Okay? So let me, for, so for your activity, I want you to compute your desirable body weight using letter A, the Tannhauser's method, and letter B, the Adore-Dionysius method. Okay, then compare the results of the two methods. Then post it in our School G account. I will be posting the link. Okay, so that's is for now. Good night and have a blessed. That is for now, and God bless. Till next meeting. See you.